Everybody, just a real fast follow-up on the final exam video. I had something about the format for the course and now for the final exam, and now I'm just going to talk about content real quickly specific to your statistics course. So I would say exam 1, there was a ton of vocabulary. Okay, make sure that you go back and you know the difference between a census versus a representative sample. Now, I will say that a lot of these definitions, you're probably better with them now than you were during exam 1 because we've been using them all semester long. So you're just like, oh, I remember now the difference between a census and a sample. So hopefully that vocabulary is not so bad, but also it's been a while since you've seen some of that. So you might not remember. Know the different sampling strategies, right? I know you knew it at the time we did exam 1, but it might have been a while. So for instance, if you're looking at grouping stuff, then there's 2 different types of grouping where the groups are prearranged before we get there. One is clustering, and the other one is stratified. Okay. There's also the other kinds. There's convenience. There's systematic. And then there's just simple random sampling, right? Simple random, or sometimes it's called random. Okay, so you need to know that clustering and stratified are the 2 that have to do with pre-arranged groups before I get there, like if I go to a hospital or I go to a polling center or something like that. And then you need to know the difference between clustering and stratified. So if you need to, go back over your notes, go back over the homework and make sure, do some reading, whatever you need to do to make sure you got the difference in those sampling strategies down cold, because it's a big difference. Okay, you need to know the reasons for studying statistics. Why do we bother? Okay, I'm going to tell you that the primary reason that we study statistics in this course is to make better decisions, right? So that we can understand statistics when we see it on the news or on a website or something like that, and then we can look at it and go, oh, see, I don't think I trust that thing because they might have done this and I don't know if they did that, and they're not telling me very well what's going on. So yeah, make sure you go back and you look at those. There were also, by the way, 8 guidelines, right, for knowing when you can trust, we'll say examining validity of a study. Yeah. When can I trust that study and when can I not trust that study? So there's some stuff we had that we need to know. Know the difference between observation and experiments, right? So there's just a lot of definitions in that very first test. The other things that were in the very first test were some basic percentage questions and error questions, margin of error and stuff like that. So there wasn't a ton of math in that first exam, but there was a tiny bit. So make sure you can do those things, okay? And then exam 2 should have been data analysis, right? We looked at frequency tables. We looked at mean, median, mode, and range. So where the range was a type of variation in our data, right, where we can talk about stuff. There was more in the lines of, okay, I'll have to look at that test. Anyway, I'm sorry, I'm looking at an old final exam. There was more in the lines of things like data crunching, actual number crunching, and being able to do stuff. We did standard deviation. Okay, so make sure that you know what an X bar means. That's the mean of the sample, right? That you've taken. Okay, so make sure that you understand that. Now, I'm not going to expect you to memorize necessarily the standard deviation formula, but you better be able to use it when you see it, right? So S equals the square root of the sum of all the X bars minus the X sub i's minus the X bars, square that guy, and then divide by n minus 1, right? Okay, so normally I put a table on this test where I say, well, what's the X sub I? What's the X sub I minus the bar, X bar? Find that difference. And then what's all that squared? And then I ask you to sum it all up, right? And then you have to divide by n minus 1. You have to know that the n is the number of data points, right? X sub I is an individual data point, X bar is the mean of the sample, and then you take the square root of it all, and the S is standard deviation. So you just really need to be able to kind of put some of this stuff together and read through those formulas and make sure you remember those. The other thing that we do in this area is box and whiskers plot. The 5-number summary. Right? So being able to find those and use them. There are other graphs in this area. So bar graph, what's the difference between a bar graph versus a histogram? Histogram. Okay, do you know the difference? Can you do a line graph? You know what a scatter plot looks like, a dot plot, all those different things. So what about, can you read a pie chart? I probably won't ask you to create a pie chart, but I might ask you to pull data off of a pie chart and tell me what's going on in there. Okay, so all of that stuff was in exam 2, being able to find information and look at the data and find stuff off of it. Okay, and then the third exam was a lot of probability. Right? It's the most recent stuff, so probably you remember it the most, but knowing if something is a fair situation, okay? Knowing the difference between an intersection, which is an and statement, versus a union, which is an or statement. With the and statements, think about that. We would multiply normally, whatever our probabilities were. With the or statements, we would add normally. But then you need to know about things that are mutually exclusive, meaning that they don't have anything to do with each other. There's no overlap. Versus things where there is an overlap. Okay? So if there is an overlap and I'm doing a union, then I can't just add, I have to what? Go back and subtract out the intersection. Subtract out the overlap. Why do I do that? Because I don't want to double count that overlap. So remember those kinds of things. Basic probabilities like subjective stuff. The difference between a subjective thing, well, remember that's based off my opinion. Empirical data, empirical is based off of actual experiments or actual things that we see happening, the trials. Theoretical, that's what we think it should be. Law of large numbers, right? That one, so think about it this way, large numbers. This is what happens when you do an experiment a large, get that, large number of times. Okay, so if I roll those dice 1,000 times, that's where the law of large numbers comes in, right? And that says that the more you do an experiment, your experimental probability will get closer and closer to the theoretical probability if it's a fair system, right? So if I'm rolling dice and they're fair dice, then if I do that 1,000 times, then the probability of me rolling, say, a 5 should be about 1 out of 6, right? Because that's the theoretical probability. But if I just roll the die 6 times, I might not ever get a 5, right? So it doesn't happen with small numbers, it happens with large numbers. So be careful of that one. And remember, there's a difference between the law of large numbers and the gambler's fallacy. Okay? The gambler's fallacy is something that a lot of gamblers believe that your luck will change. Right? Either for good or bad. Often it happens that they're on a bad streak and they think that their luck will change and all of a sudden they're going to win, so they might as well stick it out, right? So this is a fallacy or false. Because why? Because the probability for them to win never changes. Right? So they think that if they stick it out, that they're going to be okay. So fallacy, false, think that's like a lie, right? So that is not the same as law of large numbers, but I will say a lot of times I see people getting those two confused. So I want you to be sure you know the difference in those. All right, know the difference in probability with replacement versus without replacement. Okay, if there are 6 blue guys, blue marbles, whatever it is, out of 20 in a bag, let's make it 23 so it won't reduce. I don't want to have to deal with reducing my probabilities here. So if there's 6 blues in a bag of marbles, then the probability of getting the blue is 6 out of 23. If I replace that blue marble and put it back in, then the probability on my next pull out of the bag for getting a blue is what? Still 6 out of 23, right? So the probabilities don't change with replacement. Okay, that's what's going on there. However, without replacement, let's think about it. If there's 6 out of 23 the first time I pull and say I get a blue marble, okay, let's say I got a blue, okay, then I don't replace it, meaning I put it in my pocket and somebody else has to pull something out of that bag. How many blues are in there now? It was 6, I kept 1, it's 5, right? And how many total marbles are in there now? Well, it was 23, but I kept 1, so now it's 22. Okay? So that probability does change depending on what I pulled out. Now let's say, so there's that 1. What if it was a green? Okay? I pull a green out of the bag, I put it in my pocket, I don't put it back. This is the first draw. Okay? How many blues are in the bag? Well, I pulled a green out, so there's still 6, right? So in this case, the blue, the top number, doesn't change. But I put that green marble in my pocket, so what about the number on the bottom? There were 23 marbles, but now it's still 22, so that still goes down, right? Okay, so is this the same probability? No. So whether I get a blue on my pull or not, it doesn't matter. The probability for the second pull, the second draw out of the bag, does change, right? Okay, so that's the difference between with replacement and without replacement. So thinking about that, think to yourself about the probability words we have there. One is dependent and one is independent. Okay, so remember all this vocabulary. There's tons and tons and tons of vocabulary going on here. So which one of these is dependent? This one without replacement, right? These are dependent, which means the probability of the second event depends or relies on what happened the first time in the first event. Right? That's dependent. Okay? And it depends, right? If I pulled a blue, I get this. If I pulled a green, I get this, and so on and so forth. It's changing, this probability is changing depending on what happened here. Okay? So this probability depends on what happened in the initial draw, basically. The first event was I pulled a marble out, right? But on this one, the first guy, he's independent. Okay, meaning that the probability of the second does not rely on the outcome, second event, does not rely on the outcome from the first event. Okay, so in other words, I don't care if you pulled a blue out this time or a green. It doesn't matter, because when I'm replace that marble back in there, I stick it back in, the probability of getting a blue stays the same, right? Okay, it does not matter at all. So 6 blues are still in there because I put that back in there, right? So 6 blues out of 23 total. That's what's going on there, okay? So some stuff you need to be aware of. Make sure that you know how to use them. I'm not going to put a bunch of stuff up here drawing-wise, but you should be able to create a tree diagram for this probability stuff, right? You should be able to create a probability distribution. If you're not sure what that means, go back and look at the notes. Watch any videos that might be out there that could help you. Look at the exam on probability. Make sure you know what those things are, because you're going to have to create those and use them, right? Use whatever's there. Okay. Some other stuff that's on this test other than probability, exam 3. So there was a lot of probability stuff, so you better get that probability stuff, especially if exam 3 was your lowest test score, right? But there was also correlation coefficients, finding them. We did some button pushing on the calculators. We looked at lines of best fit, along with regression. For us, we did linear regression, but there's also quadratic regression and exponential regression and all kinds of other stuff. Okay, so we did all that. We looked at the errors and how to create a confidence interval. Okay, remembering that for our purposes, statistically significant in our case meant a 95% confidence interval, right? Okay, meaning that there's only a 5% chance that whatever we came up with was by happenstance, by chance. In other words, the stuff that we came up with was absolutely, we meant for that to happen, right? Okay. Make sure that you know the difference between this stuff and way up there on exam 2. I didn't mention it, but there was that 68%, 95%, what's the last one? 99.7%, I think. Is it 99.7? 97.5. I think it's 99.7. Whatever that last percentage is, there was that rule, right? So where we created our normal distribution curves. Yeah. We did all that earlier in exam 2, I think it was. So make sure that that's different from these confidence intervals. So make sure you know the difference between them. And by looking at this, we actually found out what was the sample size And last but not least, it might be new material for your class, just depending on where we are, hypothesis testing. Okay, it's kind of like the crowning jewel in the class, like sticking it all together, making sure you understand stuff. So hopefully you've got some of that in there. Anyway, that is the overarching content for the course, and those are the types of things. Now, I can't hit every single possible question that I might ask you on the final exam, and I wouldn't want to, because quite frankly, I want to be able to say, oh, I thought about this really cool question and I want to ask it, and I don't want to be tied down, right? Okay. But I want you to be able to say, oh, if I study, I'll say this, if you can work all the problems off of all 3 exams, you should for sure know at least 85% of the material on the test, okay? That last 15% might be new material, it might be things that I'm like, oh, maybe they didn't pick up on this, maybe I'll re-ask that, maybe it wasn't on one of the exams, but I'm going to pull it in, maybe it's a vocabulary word that they didn't think about before, that kind of stuff. So there's lots and lots and lots of stuff out there. Study it all, and if you have questions, let me know. I'm sorry, I can't be more specific. If you want to look at some of the review videos, go back and look at that, or work on some of those review questions that I gave you. I'm sure there's some sample problems out there from other exams to help you study. I think that's about it. So if you have questions, let me know. All right, thanks. Good luck.